Okay, we're working on problem number 1 on page 5 of the 5.5 notes, solving rational equations. So first thing we did was find an LCD. There's only one denominator in the problem, so that has to be the LCD because both of these have denominators of 1. And then we do our restriction box. The only thing that would make that denominator 0 is if I put 0 in. So after we find those two, then we multiply every single term of the original problem by x. So x times x squared. X's cancel, 32 equals 12x. Then from chapter 4, we learned that anytime you have a quadratic second degree equation, it must be set equal to 0 before you can solve it. So I needed to bring this over to the left. So it's positive here, so I subtract 12x, 12x, and I know it goes in the middle, so I put it in the middle. So now we have this. Now we're ready to continue on with our section 4.8, which is once you get a set equal to 0, you use one of your factoring patterns, which in this case is going to be double bubble. It's a trinomial leading coefficient 1. So factors of 32 that add to 12 are 4 and 8. This says the signs are going to be the same. And this says make them both negative. So -4, -8. And remember what I said, find your error right here, just like I did in a previous video. -4 plus -8, is that -12? Yes. -4 times -8, is that positive 32? Yes. So x minus 4, x minus 8. And then also from chapter 4, section 4.8, we learned the zero product rule. If A times B equals 0, then either A is 0 or B is 0. And so that will give us our two possible solutions. We just have to make sure neither solution is in the restriction box. This is x equals 4. Well, these are called potential solutions, not possible solutions, potential. 4 is not in the box, 8's not in the box, so they are actual solutions. So we show the reader that they both are valid. Neither solution is extraneous. So we show the reader that by putting them both in solution brackets to show that they're both valid solutions. And if one had been in the box, if this one had come out x equals 0, for instance, then we would cross it out and it would be extraneous. And then we would have only put 8 here. Because I have one on the test where one of the solutions is extraneous, the other is not. So if one crosses out, you pick the other. If there's only one and it crosses out, then you write no solution. Okay, so let's carry on. Let's try number 2. So for number 2, we have 3 denominators. This one can't be factored, this one can't be factored, but this one can. So as we go to write it, we need to make sure and factor that. So 4x plus 3. Ooh, remember how we learned about this? Add the opposite and get that negative up there. So let's do that. -6 over x minus 3. And then this is a difference of squares. Wow, just keeps coming back. Add the square roots, subtract the square roots. Okay, now that we have it completely factored, now we're ready to do the LCD and the restrictions. So LCD is everything we see without repeating. I see an x plus 3, I see an x minus 3, that would be repeating. So my LCD is x plus 3 x minus 3. My restrictions, x cannot be negative 3 plus 3 makes that 0, so negative 3. And 3 minus 3 makes that 0, positive 3. Negative 3, positive 3. So there's my restrictions. And like I said, if you have a highlighter on the test, I would highlight those to make sure, because I put 3 of these on the test, and one of the 3, the answer's in the restriction box. So it's a really good idea to highlight that, just so you remember to look back at it at the end. That will draw your attention up there. So now we're ready to multiply every term by the LCD. There are 3 terms, so I should write x plus 3, x minus 3, 3 times. So x plus 3, x minus 3 in this numerator, x plus 3, x minus 3 in this numerator, and x plus 3, x minus 3 in this numerator. And just like in 5.4, the complex fractions, if you found the correct common denominator, there should not be any fractions left after this step. The fraction should disappear. So let's see. X plus 3 divided by x plus 3, 1. That fraction's gone, so we're left with 4 times x minus 3. X minus 3 divided by x minus 3, 1. So we're left with minus 6 times x plus 3. Remember, plus a negative is just minus. And here, look at this. Ding! 1. Ding! 1. So all we have is 4. Look at that beautiful equation we have left. So we took this ugly, ugly, ugly mess and turned it into beauty. Simple little equation. Distribute, combine like terms, solve for x. Check the box. So we have 4x minus 12 minus 6x minus 18 equals 4. So combining like terms, we're going to have, boy, this is starting to look like Christmas here, isn't it? Wrong month. So we have 4x minus 6x, which would be negative 2x. Negative 12 and negative 18 would be negative 30 equals 4. So let's go ahead and bring that here. So negative 2x, negative 30 equals 4. Solving for x, we're going to add 30, and we have negative 2x. Negative 30 plus 30 is 0, equals 34. Divide by negative 2, divide by negative 2. X equals negative 17. I look up here and go, not in the restriction box. Woohoo! So that means it is a valid solution. It's pretty nice, huh? Okay, I think it is your turn. So go ahead and turn off the video and see if you can do 3 and 4. And we'll come back and check them together. Okay, let's go ahead and see how you did. So LCD, first off, there's no factoring, so I don't have to worry about that. I can jump right into the LCD. So LCD is write everything you see without repeating. I see a y, and I see a y plus 1. And then I see another y. The highest exponent I see on y is 1. So my LCD is y and y plus 1. X cannot equal, so go down the line. What makes y 0? Whoa, Nelly. Okay, so how about y cannot equal, because we're using the variable y. So the only thing that makes y 0 there is 0. What would make this 0? If we put -1 in for y. So our restriction should be y cannot equal 0 or -1. And of course my little crossout's driving me crazy, so I have to use my whiteout because I hate crossouts. Don't ever turn into a math nerd, okay? So 0 makes that denominator 0, -1 makes that one 0. So those are the values we have to throw out if we get either one at the end. Okay, so now let's write our problem nice and big so we can do our canceling. Oh, I see a negative, so let's add the opposite and get that up there. -16 over y plus 1 equals 2 over y. So 16 over y plus -16 over y plus 1 equals 2 over y. Looking good. So now beside every single fraction, we need to write down, write our LCD. So y and y plus 1. And remember, put it in the numerator so you don't forget that the reason we're doing this is to cancel first. Then write what's left. So every numerator now has that in it. So cancel first. Y divided by y is 1. Y plus 1 divided by y plus 1 is 1. Y divided by y is 1. Now we need to write what's left. So it's looking like 16 parentheses y plus 1. Look at no fraction because y divided by y canceled. Minus 16y. Look again, no fraction. Y plus 1's canceled, so we just have that. Equals 2. Y's canceled, so y plus 1. So look at that easy little equation we have left. So nice. So we're just going to distribute. So 16y plus 16 minus 16y equals 2y plus 2. So after we distribute, 16y plus 16 minus 16y equals 2y plus 2. Well, this is convenient. Love it. So I'm going to flip this equation over just because I like having my y on the left. So this is really 2y plus 2 equals 16, and then I just have 2 little steps to solve. And I just remembered I forgot to highlight my restrictions. I think most people that miss this problem on the test miss it because they don't pick the right LCD. They just write y plus 1, but y and y plus 1 don't have anything in common, so you have to pick both y and y plus 1 because they're two separate factors. So then we get 2y equals 14. Y is 7. We look up and go, yay, not in the restriction box. So then we go over here and write it as a solution set. Should we practice checking this one since we have an extra minute here at the end? So put 7 in for all of our y's. So we're going to do 16 sevenths. And like I said, you can do it all on your calculator. So 16 fraction bar 7 minus, or we can do plus a negative, plus negative 16 fraction bar 7 plus 1 is 8. Hit enter. And if we've done it correctly, it should give us 2 sevenths. Whoa, Kim. Sorry, I was off the screen. I'll just go over that again real fast. So 16 over 7 plus negative 16 over 7 plus 1's 8. I hit enter and got 2 sevenths. And I have 2 sevenths on this side too. So I can go, yay! I know I got this one right because what I got on the left matches what I got on